Hey Coyotes, welcome to the walkthrough for lab number 5. There's going to be 3 different calculations we go over today. This first one's dealing with the Cooper 1.5 mile run. So the basic information we have a male, we have their initials, we have their age, we have their height, and we have their weight in kilograms. For their running time, they ran their 1.5 mile in 11 minutes 57 seconds. 57 seconds. Now, this is optional. This isn't a requirement when we're doing the Cooper test, but heart rate is an optional thing. If you recall how to take heart rate, you can kind of palpate your neck area until you feel your pulse, and you can record your beats per minute. So record how many beats you feel within 60 seconds, or you can measure it at 30-second interval, times it by 2, or a 15-second interval and times it by 3. However, the full old school measuring it for 60 seconds will be probably your best and most accurate way of doing this. Now, again, this is optional. We will use this in the other 2 tests, but really what we need is just their time. That's kind of the beauty of this test. It's really, really easy. You're only looking for really one specific thing. So another optional thing is if we are doing this test inversely, instead of running the distance of a 1.5 miles, we see how far we can run in 12 minutes. You can record that information there as well. So understand this is 2 different tests really kind of on the same kind of data collection. So don't feel too obligated when you guys are picking your test and doing your test this week to have everything filled out or do both tests. Again, you're only doing the one. So just make sure you picked your information that you're doing, and I'll be able to kind of tell what you're doing. Now from there, and actually before we jump ahead, I'll go ahead and throw this up there. When we're looking at this information, specifically the relationship between your VO2 max and your 1.5 mile run, it is a linear slope downwards. So what this means is, depending on how fast you complete it, you'll have a higher reported VO2 max. Intuitively, that makes sense. The faster you run it, the higher capacity you have. So if you ran an 8-minute 1.5 mile, you would be up in that VO2 max of a 60 range, compared to if you ran it like our individual here who did almost 12 minutes, they would have a VO2 max of somewhere between that 40 to 50%. So just understand, depending on which test you're looking at, you're going to see a different relationship. So just to give you a little bit more comparison, you can see the difference here. That's why I kind of threw this right before your homework this week. So you have your VO2 max again on your y-axis. You have the 1.5 mile run on graph number A, and then you have the 12-minute, and you can see the difference in the relationship. So you have this downward sloping trend versus this upward sloping trend. And it's just take a minute, step back, and kind of walk yourself through this. If you're running it faster when you're doing the 1.5, the distance version, the faster value will have a higher VO2 max compared to the distance. The farther you run, because you're able to, you're doing it over that 12-minute period, the higher VO2 max. So just know which slope in the curve you're going with. Now from there, if we would go over to table 12.1/12.2, we'll be able to see. So remember this number right here. We're dealing with 12 minutes and 57 seconds. So 12 minutes, 57 seconds for the 1.5 mile time. We got to go to the next sheet. And we're right here. So they're roughly about 43.6%. So you'd come right here and you would write your 43%. So I am seeing some iffiness when it comes to the evaluation and comments, some lackadaisical kind of nature with you guys reporting this. Make sure we're being as detailed as possible. I always kind of compare this to saying this is a professional evaluation. If this had to go into someone's medical record or medical chart, you would want to make sure you fill this out appropriately. Okay, this is your guys' job right now as a student. So we're dealing with human beings and people. So we have to make sure we take care of them the best we can. And that means being as accurate as possible when evaluating and reporting these comments. So report the information you have at hand. Don't have to be fuzzy and fluffy with your language. Just report what you have on your data. So we ran the Cooper 1.5 mile test. This was a male, age of 20, the height of 180, the weight of 85. They ran the time of this Cooper test of 11.57. They scored a VO2 max of 43 comparative to the categories on 12.1. They fell into this category comparison to their peers, yada yada yada. That's pretty much in a nutshell. You could see that's 3 or 4 sentences. 1, 2, 3, 4. There's a reason we give you those 4 lines. It's difficult at first, but just start at the top and kind of logically walk your way down and just make sure you're as detailed as possible when you're doing this stuff. If I get this person ran at 43 and they got this, that's not enough information. Think about this. You're going into a medical record. Medical records are pretty lengthy and detailed, and lots of people usually are involved with them, doctors and nurses and exercise physiologists and specialists. We are medical professionals, guys. I don't know if you realize that yet. We are in the people business and keeping people healthy. That is a part of healthcare, or it's going to be a part of healthcare very soon. So, little side note, I know I'm getting off on a rant a little bit, but I just want to throw some kind of light on this evaluation and the importance of it. Out of this whole sheet, that's the most important because that's what other people are going to read. All right, so now we're at the George 1 mile jog test. We have a female. This is her initials. Her age is 20. Her height is 160 centimeters. Her weight is 65 kilograms. Now we have to categorize this in a gender of males as 1 and females as 0. If you recall back way in chapter 1, we can categorize or create a dichotomy with 1s and 0s. That way we can kind of hash out this lower part stuff a little bit easier because we're putting it into a unit that is workable within this stuff. So just some side information. Probably more so, this becomes more important when we're doing things in data management systems, such as, Excel is actually a data management system, or we're doing SPSS, any kind of statistical package stuff. This makes it easier for us to kind of do the math, so to say. So their jog time was 10 minutes and 45 seconds. Now, with this said, we need to actually convert this into a little bit easier thing. So to do that, we need to make it into minutes. And we have that 10 minutes there, so we don't have to do much with that. But then we have this 45 seconds, which is not in a minute form. So how can we change this about? Well, it's pretty easy. We're going to take this 45 and we're going to divide it by 60. So if we take that 45 and we divide it by 60, we get 0.75. So now when we're going to write this out, what we would do is we would say 10.75. And then from there, we go ahead and we just kind of drop everything in, plug and play. So gender, we have a female, so we're going to put a 0. For body weight, it's already in kilograms, so we just write 65. For the jog time, we're going to go ahead and write their 10.75. And then for our heart rate, we are at 171. Now, if we were to go ahead and do the math and just kind of walk down the lines, we would be able to figure out our VO2 max, which I'm going off of memory at this point, but I think it's around like 41 milliliters per kilogram per minute right there. And we could go ahead and look that up and compare that to table 12.5 and then again write our evaluation. I want to see some details in the evaluation this week, especially because we're using your guys' data when we're doing this. It's a blank sheet. You're picking one of these tests and you're running it out. So I kind of have an idea what you guys are going to do with your choice with the test, mostly because you guys aren't going to want to do the whole heart rate stuff. But I challenge you to do it. It adds one more element into your bag of tricks for you guys as practitioners. Normally, we would make you guys do all three of these tests, we would group you guys together. And, you would go out literally on campus and we would set up the test and some of you would run each test and you guys would calculate each other's numbers. But we don't get that. So this week you just have a kind of a case study of yourself when you're doing it. Now to the Rockport 1 mile walk test, and this is modified. Remember, there's a couple different variations of the Rockport test. This was built for an older population, but we can modify it for an age range of 18 to 29. So with that said, make sure you kind of fall in that range if you're doing this test. It's not uncommon for, especially here at Cal State San Bernardino, we have a mixture of age groups and people. So if you need a little bit of help with that, just email me and we'll kind of work it out for you. So this is probably more similar to the George test, just with the way it's set up compared to the Cooper test. So gender, we have a female, we have some initials. Age group is 20. The height is 165 centimeters and the weight is 65 kilograms. Again, we're going to categorize males as 1, females as 0s. Their walk time in minutes and seconds was 16 minutes and 14 seconds. Again, we need to convert that, really dealing with that 14. How do we do that? Again, we're going to take the top number being 14. We're going to divide it by 60. And then from there, we get our time, which is going to be 23. So from there, we're going to write 16.23. And then we're measuring heart rate as well. And we have 131 beats per minute. So just looking at that number, is that a high heart rate or is that a low heart rate? Is that resting heart rate? So what time period do you think you're actually measuring that heart rate? Is it before or after the run or during the run? Can you measure heart rate during your run? If we're in a lab setting, you can. If you have a heart monitor, it's easier to do that. But most likely this is going to be at the end of the event when the intensity is probably the highest. So just something to point out. If all fails when you're looking at these numbers, is logically walk through this and pick out the information you know. And, case in point, if we are dealing with a mile test and we see that they walked 16.14, on average, what would you guys do when you guys would walk a mile? Would it take you 16 minutes to walk a mile? From there, you have a metric you can kind of base this off of. What about the heart rate? Same thing. Is it a high heart rate, moderate heart rate, kind of in the middle? This is not the highest heart rate out there, but it's definitely above resting, which resting would be somewhere between 60 to 100. beats per minute. This is 131. This person's moving at a moderate, good pace. So from there, we're going to head and just kind of fill in, drop it in. So we have a 0. We have 65 pounds or kilograms, excuse me. Still thinking like an American. Our jog time is 16.23. And our heart rate is 131 beats. From there, we go ahead and we do our math. And lo and behold, what do we get? Roughly, it is around 35.8. And then from there, we have our number we can kind of compare it to on table 12.7. That was a tongue twister. And we can report that information there, average, above average, etc., etc. And then when we're doing our evaluation, what do? We just report the information we have. We have our gender, our basic information. We have their actual results of their time on their test. We have their score. We see how that compares to this. And then from there, we can kind of make that arrangement. So this is a pretty straightforward lab for this week. Nothing too crazy. The biggest challenge, I think, is you guys getting out there and collecting your data and then making sense of it. So if you need help, let me know. But it seems like you guys are doing pretty fantastic with this stuff. So keep the good work going.